Hello, pre-algebra students. This is Chapter 8.2, Linear Equations in Two Variables. In previous work, we've solved equations in one variable. Now we're going to learn to find solutions of equations with two variables. Let's begin. An example of an equation in two variables is 2x minus y equals 5. A solution of an equation in x and y is any ordered pair that produces a true statement when the values of x and y are substituted into the equation. Let's work through some examples of finding solutions for an equation in two variables. Our first ordered pair is 1, -3. In order to check if this is a solution, we simply substitute the values into our original equation. So our original equation was 2x minus y equals 5. Let's substitute in our values of x and y. X is equal to 1, and y is equal to -3. Now we simply solve. 2 times 1 is 2. We're going to add plus 3 because we're subtracting a -3. And we see that this statement, when simplified, is true. So 1, -3 is a solution of 2x minus y equals 5. Let's work another example. Is the ordered pair 4, 7 a solution for 2x minus y equals 5? Let's substitute in and find out. We'd have 2 times 4 minus 7 equals 5. 2 times 4 is 8, minus 7, 1 is not equal to 5. So 4, 7, as the ordered pair, is not a solution of 2x minus y equals 5. Here's your first set of checkpoint problems. Tell whether each ordered pair is a solution of 3x plus 2y equals -8. Press pause while you work. There's more to come. Now let's work through a real-world example that uses an equation in two variables to describe the flow of lava toward the ocean. The Hawaiian volcano Mauna Loa has erupted many times. In 1859, lava from the volcano traveled 32 miles to the Pacific Ocean at an average speed of 4 miles per hour. We can use an equation to describe the relationship between the distance and the time. The distance, d, in miles from the ocean, t hours after it left the volcano, would be approximated by d equals 32 minus 4t, okay? Because remember, we have a lava flow that's traveling at approximately 4 miles per hour and traveling 32 miles total. Our first step in finding the solutions for this equation is to make a table. Let's begin with the value of t equals 0, so no time has passed. Our substitution would be d equals 32 minus 4 times 0. Therefore, our distance will be 32 miles. If t equals 1, our substitution would give us a solution of 28 miles. If time equals 2 hours, let's fill that into our table here. Our distance would be 24 miles. So we could now rewrite these as ordered pairs: 0, 32, 1, 28, and 2, 24. If we wanted to find out how long it took for the lava to reach the ocean, we would need to create an equation in which d equals 0. So for what value of t would d equal 0? All right, well, let's go ahead and solve for t in this equation here. Let's rewrite the equation with d equal to 0. And now we'll solve for t. We'll subtract 32 from each side, giving us -32 equals -4t. We'll divide each side by -4 to solve for t, and that gives us a value of 8. So it takes the lava about 8 hours to reach the ocean. Now let's move on to graphing an equation in two variables. The graph of an equation in two variables is the set of points in a coordinate plane that represent all the solutions of the equation. An equation whose graph is a line is simply called a linear equation. Let's begin by graphing y equals 2x minus 1. We'll start by making a table of solutions. So we're simply going to create a chart for x and y. We're going to create a set of inputs and outputs. We'll begin with x being equal to -2. If we substitute -2 into this original equation, y will equal -5. Then we'll simply go up by a value of 1. If we substitute in -1, y is equal to -3. If x is 0, y is equal to -1. If x is equal to 1, y is equal to 1. And if x is equal to 2, y is equal to 3. So what are our ordered pairs? They'll be -2, -5, -1, -3, 0, -1, 1, 1, and 2, 3. Our final step will be to graph these points on a coordinate plane. All right, let's go ahead and graph these ordered pairs on this coordinate plane. So we begin with -2, -5. Then we have -1, -3, 0, -1, 1, 1, and 2, 3. Notice that these are on a line. All the points lie on a line. So there is our linear equation. Any point that lies upon this line is a solution to our equation y equals 2x minus 1. Try these 4 checkpoint problems on your own. Graph each equation. Begin by making a table of solutions, listing the solutions as ordered pairs, and then graphing the ordered pairs on a coordinate plane. Press pause while you work. We have a couple more ideas to tackle when you're finished with this. We're going to finish up Chapter 8.2 by looking at horizontal and vertical lines and at equations as functions. The graph of the equation y equals b is the horizontal line that goes through the point 0, b. So it passes through the origin at point B. If we were to graph the equation x equals a, that would be the vertical line that passes through the point A, 0. So it goes through the origin at point A. Let's graph a couple of solutions that look like this, just so you can visualize what it would look like. Let's begin by graphing y equals 3. We know that the graph of the equation y equals 3 is the horizontal line that goes through point 0, 3. No matter what value we put in for y in a set of x, y coordinates, it will always equal 3. Okay? So here is the graph of y equals 3. It's simply the straight horizontal line through the origin and point 3. Now let's graph x equals -2. The graph of the equation x equals -2 is the vertical line that goes through point -2, 0. No matter what value we give for y, this line will go through the x value of -2. In the equations that we graphed in previous examples, the vertical line test shows that y equals 2x minus 1 and y equals 3 are both functions. However, x equals -2 would not be a function. A function whose graph is a non-vertical line, such as this example here, is called a linear function. When the equation of a linear function is solved for y, the equation is called the function form. You may find it helpful to write an equation in function form before graphing it. Let me show you an example of function form versus not function form. This equation, 3x plus y equals 7, is not in function form. It doesn't show us that the equation is being solved for y. If we were to rewrite this equation as y equals 7 minus 3x, we would now call that the function form. Let's work through an example where we're going to write an equation in function form and then graph it. We'll begin with the equation x plus 2y equals 6. First, we'll write it in function form. We want to have an equation where y equals x plus or minus something, correct? So let's begin by moving the x to the opposite side of the equation, which will give us 2y equals 6 minus x. Now we want to isolate y, so we're going to divide both sides of the equation by 2, which will give us y equals 3 minus 1/2 of x. Here's our equation in function form. However, we will rewrite this so that our x comes first. This is just the generally accepted nomenclature or way of writing the equation. Now let's move on to our next step, which will be to graph the equation using its function form, and we'll start by making a table of solutions. All right, let's begin with our table of solutions. I'm going to use values of x that are multiples of 2 so that we get a whole number solution. So I'm going to start with -4 as our first value of x. If I substitute that into our original equation, my output value for y is 5. Now I'm going to use -2, which gives me a value of 4 for y. 0 gives me a value of 3. +2 gives me a value of 2. +4 gives me a value of 1. So our ordered pairs will be -4, 5, -2, 4, 0, 3, 2, 2, and 4, 1. Okay, let's go graph this. All right, let's enter these ordered pairs. We begin with -4, 5, which will be right here. Next up is -2, 4, 0, 3, 1, or excuse me, 2, 2, and 4, 1. Now we'll finish this off by drawing a line through our points. Sorry, that's not perfectly straight. However, there is our solution to the equation y equals -1/2 x plus 3. Okay, folks, here are your final 2 checkpoint problems for this chapter. For number 9, please graph y equals -1 and x equals 4. You may do this on the same coordinate plane. Then tell me which of these is a function. Finally, write 2x minus 3y equals 3 in function form, and then graph the resulting equation. Thanks for your work today on linear equations with 2 variables. I'll see you tomorrow for more practice on this concept. Have a great night.